18 days. Just 18 days from now, we might finally get an answer. Currently, something is hurtling toward Earth from beyond our solar system, moving at over 246,000 kilometers per hour. NASA says it's a comet. But something about it doesn't add up. It's brighter than any comet we've ever seen. It's flying on a path so precise, it almost feels programmed. And it's doing things that our physics can't explain. December 19, 2025. This is our only window. Hubble, James Webb, every telescope on Earth will be locked onto one single point in the sky. And after those 18 days, we may finally know. Is this the strangest comet in history? Or something humanity has never encountered before? This is the story of 3I Atlas. And it's unfolding right now. It all started on July 1, 2025. A small, unexpected point of light appeared on a telescope feed from Chile. The Atlas survey caught it. At first, it didn't look like much. Just another object drifting through space. They gave it a temporary code, A11PL3Z. No one knew what it was. It could have been an asteroid. Maybe a comet. But then, astronomers ran the orbital calculations. And everything changed. It wasn't from around here. This thing wasn't part of our solar system. Its path, its speed, its angle, none of it matched anything bound to the sun. That made it special. Very special. Because this is only the third object in history ever confirmed to come from interstellar space. Let's rewind for a second. The first was 1I Oumuamua in 2017. It had a long cigar shape and mysteriously sped up as it left. The second, 2I Borisov, showed up in 2019. It looked and behaved more like a regular comet. And now, we have 3I Atlas. But this one is different. It's coming from the direction of the galactic center. That bright, dense heart of the Milky Way. It's been traveling for millions of years, alone in the dark between the stars. And now, it's here. Just weeks away from the closest encounter we may ever get with something born beyond our sun. Let's talk about what makes this object so weird. We're not just looking at a bright rock flying through space. We're looking at something breaking every rule in the comet playbook. So here they are, the 5 things about 3I Atlas that science can't fully explain. Anomaly number 5, the super brightness. Imagine switching on a flashlight. It lights up. Then it gets brighter and brighter, until it's 7 times brighter than you ever expected. That's what 3I/Atlas is doing. Typical comets brighten as they get closer to the sun, maybe 2 to 4 times brighter. 3I/Atlas? 7.5 times. That's not a normal jump. That's a signal. Scientists at Lowell Observatory double-checked the data. And again, same result. Why? Could it be ultraviolet ices we've never seen? Could the surface be cracking apart, exposing something new? Or could it be something else? Anomaly number 4, the reversed hail. The solar wind is no joke. It blasts particles outward from the sun at around 400 kilometers per second. It pushes everything away. But 3I/Atlas? It has a tail that stretches 1 million kilometers, pointing toward the sun. Animated visual, solar wind versus reversed hail. That's like trying to swim up a waterfall. The pressure needed to do that is off the charts. How much pressure exactly? 1 million times stronger than the solar wind itself. This isn't just a strange effect on a telescope lens. A Japanese astrophotographer named Mitsunori Tamura captured it, and professional astronomers confirmed. It's real. Anomaly number 3, the phantom acceleration. If you throw a rock into space, it follows a predictable path. Gravity decides everything. But not in this case. 3I/Atlas is accelerating. And it's not because of the sun. It's not being pulled by any planet. This is something called non-gravitational acceleration. A mysterious push, like a force acting from within the object itself. And here's where it gets wild. The data shows this effect is statistically 10 sigma strong. What does that mean? It means the chance of this happening randomly is less than 1 in 100 sextillion. Normally, comets can accelerate a bit due to gas jets. But for 3I/Atlas to move like this, it would have to lose 10% of its total mass in just 2 months. That should have torn it apart. But it's still intact, still stable. How? Anomaly number 2, the Jupiter encounter. Circle your calendar. March 16, 2026. That's when 3I/Atlas will pass extremely close to Jupiter. And we mean extremely. Show graphic, Jupiter, trajectory, Hill sphere. Its projected path takes it to within 53.445 million kilometers of Jupiter. Why is that number important? Because Jupiter's gravitational zone, called the Hill radius, ends at 53.502 million kilometers. That's a difference of just 57,000 kilometers. In space terms, that's surgical precision. Think about it. This object has drifted through millions of years of interstellar chaos. It passed countless stars, gravity wells, and random dust clouds. And yet, it ends up here? Right at the edge of Jupiter's influence? Harvard physicist Professor Avi Loeb ran the numbers. The odds of this happening by chance? 0.00004%. That's about 1 in 2.5 million. Anomaly number 1, the perfect trajectory. And this is the strangest one. Let's map out where 3I/Atlas has been, and where it's going. Animated map, solar system path timeline. It passed just 29 million kilometers from Mars on October 3rd. Then it moved behind the Sun, completely hidden on October 29th. On December 19th, it comes closest to Earth at 269 million kilometers. Then it heads to Jupiter's Hill radius on March 16th. This isn't random drifting. It looks almost choreographed. The odds of this sequence of events lining up naturally? 1 in 20 million. That leaves us with 2 options. 1. We just got incredibly lucky. Or 2. This trajectory was planned. Not everyone agrees on what 3I/Atlas really is. 2 main camps have formed, each with its own explanation. NASA's view, a natural interstellar comet. In November 2025, NASA held a press conference. Their position? Clear. 3I/Atlas is a natural interstellar comet. According to their scientists. The extreme brightness? Possibly caused by CO2 outgassing or highly volatile ices. The acceleration? Could be due to asymmetric gas jets, just uneven pressure from internal gases. The precise trajectory? A lucky coincidence. Unlikely, but not impossible. Then came the data from the James Webb Space Telescope. It revealed something unexpected. Over 96% of the outgassing material wasn't water. Instead, it was dominated by carbon dioxide, with traces of cyanide and nickel. Materials often found in natural comets within our own solar system. In other words, from NASA's perspective, there's no need for exotic theories. Everything seen so far can be explained. Avi Loeb's view asked bigger questions. But not everyone is satisfied with that explanation. Professor Avi Loeb, from Harvard, who previously studied Oumuamua, sees a different picture. He's identified 14 separate anomalies in the behavior of 3I/Atlas. And when he combines them statistically, show calculation on screen, he estimates the chance of this all happening naturally is less than 1 in 10 quintillion. That's 1 in 10. As he puts it, if it flies like a probe, accelerates like a probe, and arrives at just the right place, maybe we should consider that possibility. Shows snippet of Avi Loeb's published paper. But Loeb isn't making a bold claim. He's not saying it is a probe. He's saying, let's get the data. Let's keep our minds open. And now, that's exactly what's about to happen. Mark the date. December 19th, 2025. That's when 3I/Atlas will pass its closest observable distance from Earth, 269 million kilometers away. And for scientists around the world, this is the moment they've been waiting for. So what's the plan? Let's break it down. First, the Hubble Space Telescope. It will capture the highest resolution images possible, focusing on the nucleus, if it can even be seen through the dense gas cloud. It'll also help measure the object's true size with extreme precision. Then comes the James Webb Space Telescope. Webb will scan 3I/Atlas using its powerful infrared spectrometers, breaking down the light to analyze the chemical composition in fine detail. It will also attempt to measure the speed of the jets, those powerful outflows of gas we've seen bursting from the object's surface. But space telescopes aren't working alone. Some of the world's most advanced ground-based observatories are in position too. Gemini South in Chile, Mauna Kea in Hawaii, the Very Large Telescope in the Atacama Desert, and the Lowell Observatory in Arizona, where much of the early tracking took place. Thousands of scientists, hundreds of instruments, all focused on one goal: measure the jet velocity. Because that one number could change everything. Here's why it matters. If the jets are moving at just a few hundred meters per second, it's likely from natural sublimation, like ice evaporating in sunlight. If they're clocked at a few thousand meters per second, that's closer to chemical propulsion, the kind used in spacecraft. And if they're moving at tens of thousands of meters per second, we might be looking at something that works like an island thruster. One number, one measurement. And it could tell us whether this is just a strange rock or something else entirely. But the story doesn't end in December. There's another critical moment on the horizon. March 16, 2026. That's when 3I/Atlas will reach Jupiter. It won't collide, but it will pass deep into the planet's gravitational domain, what astronomers call the Hill radius. It's also near the Lagrange points, stable regions in space where an object can remain in orbit without using fuel. And that's where things get even more interesting. Some researchers have started to ask a bold question. If this object is a probe, or even just a shell of one, could this be the ideal spot to release something smaller? Tiny satellites, observation devices, self-guided payloads designed to linger in Jupiter's orbit. Right now, NASA's Juno spacecraft is already there, and it's watching. If 3I/Atlas drops mass, emits any unusual signal, or leaves behind even a trace of debris, Juno will detect it. One spacecraft, one giant planet, and one interstellar visitor, all crossing paths in a moment that may define how we look at the cosmos for decades to come. Whatever the answer turns out to be, this is the first time in human history that we have the tools and the timing to study an object from beyond our solar system in such incredible detail. We've had visitors before. Oumuamua came in 2017, and it was already on its way out before we realized what it was. Then Borisov in 2019, a more typical comet, but it moved too fast, too brief. Now, with 3I/Atlas, we're ready. This time, we knew in advance. We organized, coordinated, and prepared. Around the globe, telescopes are tracking every movement. Data is being shared in real time. Scientists in every country, working together. No borders. No politics. Just science. And you are living through this moment. In just 18 days, we'll capture some of the most revealing data we've ever seen. In 3 more months, at Jupiter, the story may take another dramatic turn. This is why we look up. This is why we explore. Not to chase the answers we hope for, but to find the truth, even if it surprises us. And that truth? It's coming closer. Every hour. Every orbit. Every signal. It's almost here. This is the official channel tracking everything about 3I/Atlas. I'll be covering every major update. On December 19th. On March 16th. And every discovery in between. So make sure you subscribe. And turn on notifications, so you don't miss what happens next. And tell me in the comments, what do you think 3I/Atlas really is? A comet? Or something else entirely? In 18 days, we begin to find out.